Okay, so Drew had promised us 7 scintillating slides, and I think we got them. Up next, we have Jeff Moffat, who's a mechanical engineer with Real Property Services at, I was about to say Public Works and Government Services Canada. It's an old habit. Public Services and Procurement Canada. So Jeff, please join me up here, and if you could tell us a little bit more about yourself, that'd be great.
Thanks, Michelle. So my name's Jeff Moffat. I'm a mechanical engineer for Public Services and Procurement Canada, the old Public Works for the federal government. I work in our Environment, Health and Safety Directorate, responsible for the development of programs and policies related to the safe operation of the building systems within our federal building portfolio. So I'm here today to talk a little bit about our Legionella management program. So who are or what is PSPC Real Property Services? We're the Government of Canada real property expert. We're responsible for managing government real property holdings for the federal government. We also offer professional and technical real property services to other custodial departments within the federal government. And in our role, we are responsible for providing safe, healthy, and productive working environments at approximately 1,500 locations from coast to coast to coast in Canada. That include approximately 350 Crown-owned buildings, as well as about 1,150 leased sites from private sector landlords. In those locations, we house approximately 260,000 federal public servants who work for 99 departments and agencies. So we have a very diverse real estate portfolio ranging from Canadian heritage properties such as the Parliament buildings and a lot of other heritage structures across the country. We also have large commercial buildings. Up in the upper right-hand corner, there's a building here in Scarborough, as well as large government complexes, mostly located within the Ottawa area. About half of our portfolio is in Ottawa, but also distributed throughout the country. And then we also have campus-type environments that can have a mix of large and smaller sites. So this also leads to what Aziz was saying earlier in terms of responsibilities for distribution systems. Municipalities will bring the water up to the property line, but then we're responsible for the operation of that system throughout the rest of the campus and within the buildings. So having a large, diverse portfolio that's been around for quite a long time, we're now getting to the point where we're at midlife refits for a lot of our buildings, which presents a lot of opportunities for us, especially around Legionella management. So here in Toronto, we have the 25 St. Clair building, which is undergoing a major recapitalization worth over $300 million. You'll see the old building at the top there, and then the rendering of what the new building would look like. The current building does have a water source cooling tower in it, but the new building is looking at going with a geo-exchange loop. So that will significantly reduce the risks associated with Legionella because we'll no longer have a cooling tower at that site. I believe they are also looking at putting a dry cooler or an air-cooled chiller as backup to that system. But again, that would not have any water source associated with it. We also have longer-term portfolio plans as well. So the campus that I was mentioning in Ottawa called Tunney's Pasture, just west of downtown, it's a multi-hectare site that's undergoing a 25-year master plan to redevelop the site into a mixed-use development that'll contain both commercial, residential, and federal government buildings. And this particular site as well is served by a district energy system, currently on a steam-based system, but will be converting to a low-temperature hot water system. So the cooling for this particular district actually comes from the Ottawa River. So again, here too, we don't have cooling towers. We're using river water for cooling the buildings at these sites. So again, opportunities for removing risks associated with Legionella growth. It does present, however, some challenges when moving from a steam-based system to a low-temperature hot water system when we're talking about the generation of domestic hot water for the buildings, because we'll no longer be able to, through the district system alone, generate water temperatures in the 60 degrees Celsius range. So we're looking at doing sort of a two-stage production of domestic hot water, where primary heating will come from the district system, and then you'll have supplemental heat provided so that we can get temperatures outside of the Legionella growth range. So why is Legionella important for PSPC? We've been hearing about it this morning from the other speakers, but there's been increasing number of cases associated with Legionnaires disease in Canada and internationally. And as I mentioned before, we are responsible for the safe, healthy, and productive working environments of 260,000 federal employees. And we also have obligations under the Canada Labour Code of Canada regarding the use, operation, and maintenance of our heating, ventilation, and air conditioning systems. And we're also being informed as well by new industry regulations or other jurisdictional regulations, standards and industry guidance related to Legionella, such as ASHRAE, the Quebec cooling tower regulations, as well as New York City also has regulations related to cooling towers. Having said that, we're not new to Legionella management at PSPC. We've been involved with it since 1985 when we developed our first guideline related to Legionella management. In 2005, that guideline was updated following an outbreak here actually in Toronto where 20 people died. And then again in 2012, following the Quebec City outbreak where 13 people died, we took an opportunity to not only review the guideline and make it into a standard for our organization, but also we did a review and assessment and testing of our high-risk Legionella susceptible systems nationally. I do need to mention that our particular standard applies to our federal portfolio only. It's not mandatory to be applied in other jurisdictions or even within the federal family to other custodial departments. They are starting to adopt it, but we're not the central agency that is responsible for their programs. Since 2013, we've been monitoring and doing continual improvement on our Legionella standard. There have been 3 addenda that have been issued since 2013. Application of the standard for 3 years led us to understand that there was a need to help define communication requirements. As you'll see as we move forward, there's a lot of people that can get involved when we're talking about Legionella management. So in 2016, we developed our internal Legionella communications protocol, which helps to standardize communication approaches. And we've also started to develop leasing clauses to address those 1,150 leased portfolio sites that we have within our portfolio. In 2017 and 18, at the federal level, we were part of a review of the National Building Code of Canada, looking at heating, ventilation, and air conditioning systems and improvements that we can make on the design side for minimum requirements associated with reducing risks for Legionella growth. That's currently out of public review, and it will form part of the 2020 code release. Which will hopefully then flow down into provincial building codes thereafter. There was also an interdepartmental committee on Legionella that was formed to bring together various federal departments with different responsibilities associated with Legionella management. So there was Public Services and Procurement Canada from the building operations side, the National Research Council, who are responsible for the National Building Code, and also Health Canada as well. So at PSPC, we view the risks of contracting Legionnaires' disease similar to a fire triangle. For those of you who might be familiar, to have a fire, you need to have a fuel source, a source of ignition, and heat for a fire to occur. If you can take one side of that triangle off, you remove the fire. For us, we view it as the 3 sides of the triangle as being 1, You need to have bacterial growth of Legionella to a certain level. You need to have aerosolization of that bacteria or potentially aspiration of the bacteria, but we focus more on the aerosolization side of it. And then also a susceptible population who gets exposed to it. We have zero control over the susceptible population side because we don't do medical screenings of everybody who comes into our building to assess your underlying health risks. So we can't control that side at all. The one that we can control a lot of is bacterial growth. So that's through good operation, maintenance, design of systems, as well as validating that that those measures are effective at controlling the growth of Legionella. The other side is aerosol exposure. We have limited abilities to control that depending on the type of system that we're talking about, because certain mechanical systems, just by their very nature, are designed to aerosolize water. Cooling towers are a good example, or showers themselves too. You're standing in an aerosolized water stream. So there again, we're looking at controlling bacterial growth. So that'll be the real focus of what I'm going to talk to you about. So what are those conditions for Legionella growth? Legionella likes to grow between 20 and 50 degrees Celsius. Below that is more in a dormant state, and above that is when you would start to have a kill rate on the bacteria. Also, water cleanliness side of things. You want to make sure that you're not having a lot of sedimentation, scale, biofilms, or nutrients in your water that can feed the bacterial growth. And then stagnation, water stagnation. So we want to avoid having dead legs in our systems and also avoiding low flow or no flow conditions in our systems. One thing that we often have to talk about with some of our energy-focused engineers is on the domestic hot water side, where they often talk about turning down hot water tank temperatures and or shutting off your recirculation pumps on the weekends to save energy. So there we want to make sure the water continues to flow and also make sure that when we're generating hot water, that it is actually hot and not within the growth temperature range. So that brings me to our standard. So our standard is a mouthful, MD 15161. Control of Legionella in mechanical systems. Don't ask me where the MD 15161 comes from. It was inherited from the previous guideline, and there doesn't seem to be any reason for how that was assigned. Because we're a commercial building operator, the types of systems that we focus on are those that are typically present within our commercial building portfolio. The requirements of this standard have been geared towards a commercial building portfolio and may not be fully appropriate for healthcare facilities or long-term care facilities where you have a more susceptible population. So those systems that we look at are cooling towers, open water systems, which can be a combination of ornamental water features and rainwater storage tanks or other devices like that where we're storing water and then potentially reusing it within our facility. Domestic cold water systems, domestic hot water systems, humidifiers, and drain pans. And for all of those different system types, we have different design criteria, installation criteria, operation and maintenance criteria, bacterial testing criteria, as well as reporting criteria. Those last three elements form part of what we call a Legionella Bacteria Control Management Program, or LBCMP. This is very similar and consistent to what you're going to be learning about this afternoon with the development of a water management plan. So if we look a little high level at what an LBCMP contains, it's an on-site accessible manual that is specific to each building. Our standard requires that it is certified by a professional engineer. That doesn't mean that the professional engineer works in isolation in the development of it. It is really a team effort that requires property facility management to be involved, the building service technicians to be involved. You want to have your water treatment specialists involved in the development of the plan. And then there's several forms that form part of the program as well. One being a key contact list for individuals related to the management of the facility, an inventory of the Legionella susceptible systems that would be in the building, as well as a hazard and risk analysis of those systems in the building. We also require the preparation of a simple system schematic indicating water sampling locations, as well as ensuring that there are operation and maintenance procedures, which may include chemical treatment for those various systems. We also require a maintenance log to be kept so that you can make sure that all of the required maintenance activities have been done, as well as the testing log for the various systems. So again, too, it creates a historical snapshot for those particular systems that can be looked at when you're reviewing the plans or if you encounter issues during their operation. The other thing that's not on this slide, but that's important, is that these plans have to be reviewed and updated at a minimum of every 5 years, or if there are major changes to equipment on site. On the design and installation side, there are some additional specific requirements for some of the various system types, but basically we're looking at following manufacturer recommendations, ensuring that you have accessibility for the maintenance and testing of your systems. This is critical because when it comes to controlling Legionella growth, you have to be able to do your maintenance on the systems. Avoiding stagnant water, as I mentioned before, and where possible, operating temperatures outside of the Legionella growth temperature range. Not always possible, especially when you're talking about cooling towers, because they do operate right in the middle of that range. Next key requirement is minimum operation and maintenance requirements for those various systems. So we have requirements for startup of equipment, shutdown of equipment, inspections of equipment. There's minimum frequencies and requirements. Cleaning of the equipment, again, minimum requirements, frequencies, and procedures. Disinfection of the equipment, as well as water treatment requirements for cooling towers and open water systems. So as I mentioned before, it's important to keep a log of maintenance. So we use a computerized maintenance management program or system that includes both the maintenance checklists that then become work orders for our maintenance technicians to go out to site and go through the various maintenance activities. What this system also allows you to do is track and schedule those maintenance activities and to run reports on their completion and also see if there's any outstanding maintenance actions that have not occurred. These maintenance checklists basically follow the requirements that are within the standard, equipment manufacturer recommendations, recommendations that come from the water treatment supplier, as well as the recommendations that are site-specific that would have been developed when the LBCMP was put in place. A good example could be cooling towers. We often see cooling towers installed in 1 of 2 locations, grade level or on a roof. Grade level can pose problems from time to time, especially if there's lots of trees surrounding them, because trees like to drop a lot of organic matter at various times of the year, which can then go into the cooling tower and provide nutrients for the growth of the bacteria. So often those sites have additional cleaning procedures that are scheduled at those times of the year when they know that there's going to be increased organic load in the system. And then the physical maintenance that we're looking at doing primarily is regular visual inspections of equipment for conditions that could promote the growth of Legionella. So looking for biofilms, scale, buildup, organic matter, any deposits. And then making sure that we clean those systems or disinfect them if there's any of those conditions present, as well as trying to identify and correct any operation issues that could promote the growth. So lack of flow conditions, could be a valve that's seized, could be a pump that's turned off or failed, could be a chemical dosing pump that's failed. So it's identifying those issues as quickly as possible and correcting them. So if we look at the summary of what the operation and maintenance activities are, within our standard. I'll go through the cooling tower one in more detail, but maybe skip over the rest because there's a lot. But for cooling towers, if we break it down, each system type basically has 4 main categories of maintenance actions that occur: inspections, cleaning, disinfections, and then water treatment if there is a need for that. So for cooling towers, we have procedures that shut down or startup of the towers, as well as weekly, monthly, and annually for those towers that operate year-round and are not seasonally operated cooling towers. We also require, at a minimum, cleaning at startup and annually for those systems, or as required based on those weekly or monthly visual inspections that occur. Disinfection of the towers is required at system startup, and also when required by bacterial testing results, which we'll talk about in a minute. Open water systems are similar, but they have less mandatory frequency associated with it. Drain pans, there we're focusing more on making sure that drain pans are draining properly and that we don't have stagnant water in them. So we do look at a difference between primary air handling equipment, which would be like main HVAC units serving multiple areas in a building, versus a terminal HVAC unit, which could be just locally within a space, a small fan coil unit. On humidifier side too, we have differences in terms of maintenance requirements based on whether or not the humidifier is a steam-based system, so high temperature where you're getting bacterial kill, or if it's a non-steam system like an adiabatic unit that could be operating in growth temperature range for Legionella. On the domestic cold water side, again, we have inspection requirements. The main focus here on the potable water side is to make sure that we don't have dead legs in the system, eliminating those dead legs. So there would have been an assessment when the LBCMP was first created, and then we want to reevaluate those on a regular basis. Domestic hot water system side, we're focusing on making sure that the water is hot. So checking the set points of the tanks to make sure they haven't changed, and also checking the water temperature coming off of those systems and your recirculation lines to make sure it's out of the growth temperature range. So the ways that we can control Legionella growth, for the systems where we have a water treatment system installed on it, so cooling towers, open water systems, we want to make sure that it's a customized program to both the equipment that's on site and the materials, excuse me, and the materials of construction of the piping materials. What we don't want to have is somebody dumping in a lot of chlorine and causing a lot of corrosion in a system, because that leads to 2 things. One, it's going to decrease the service life of your equipment and you're going to have to replace it more frequently. But also it's going to add a lot of risk factors associated with Legionella growth. It can add the nutrients, but it can also provide areas for the bacteria to be sheltered from any chemical treatment. So the program needs to be adjusted based on testing results that are done regularly by our chemical treatment specialists. So looking at the pH of the water, conductivity, to name a few. And then also inspections based on what they're seeing in terms of the system itself. Is there any corrosion buildup or any biofilms? And are there adjustments that need to be made? We also want that program to be a balanced mix of oxidizing and non-oxidizing chemicals, so fast acting and longer acting, to maintain a residual in the system. And then also we want to make sure that, again, that program doesn't damage the system. Other ways that we look at controlling Legionella growth, again, temperatures, key one, especially when we're talking domestic hot water systems. We want to keep it outside of the growth temperature range. We also use hot water flushes occasionally to remove any potential bacteria in the system. So 50 degrees Celsius, you're going to get about a 90% kill rate of the bacteria in about 2 hours. That's not very effective. 60 degrees Celsius, 90% kill rate in about 2 minutes. which is why we want our storage tanks to be set at a minimum of 60 degrees Celsius. And then at 70 degrees Celsius, if we are doing a hot water flush, we're going to get a rapid kill rate on the bacteria at 100%. So we do have flushing time minimum requirements where we'll raise the temperature of our storage medium to 70 degrees Celsius and then progressively flush through the system for 20 minutes at each fixture. The other way to remove risks associated with Legionella growth is to actually remove the water. Legionella needs a moist environment to grow. So if we can remove those dead legs where they're present, ensure that our drain pans are draining properly, and also shut down systems and drain them if they're not in use. So if you have a cooling tower that is cycling on and off and you only have it there for backup, don't pre-charge it ready to go. You need to do your startup when you need it, and then if you're not using that tower, make sure that it is drained. That brings me to the last key requirement of the standard, which is associated with our minimum bacterial testing. We're not reliant on one method at PSPC. We use 3 different types of testing to look at total bacteria, general bacteria, not Legionella specific, as well as DNA specific for Legionella. And we've established minimum frequencies, action limits, and action protocols for those testing results. So those test types that we use is dip slide testing for general bacteria, Legionella culture testing, which will give you detections on living Legionella within your system, as well as the use of quantitative polymerase chain reaction testing, or a DNA-based test that'll give you presence of living and dead Legionella in your system. So I'll talk a bit about when we use those. It's a little bit different than culture testing. And the purposes of our bacterial testing requirements is to approximate the Legionella bacteria count in our systems, trigger any necessary bacterial control measures, and to provide due diligence and validation on the effectiveness of our operation and maintenance activities in actually controlling the growth of Legionella. Again, think back to that triangle. The bacterial growth side is what we're trying to attack. So here, this is really the validation step. We do have 2 different testing modes within our standard. There's the normal mode with the normal assigned frequencies, but we also have an emergency mode, again, based on risk, which would add a weekly qPCR test for systems. And what can trigger that is if there are multiple reported cases of Legionnaires disease within the past month, within a 10-kilometer radius of our buildings. It can also be triggered if a particular system has undergone multiple unscheduled cleaning and disinfections within the past 3 months, or if regional health authorities direct more stringent bacterial testing. The challenge we have with this is we don't always become aware that there have been multiple cases within a 10-kilometer radius of our building. Often the way we find out is through the media, which can have a certain lag to it. So we are trying to establish greater contacts with our municipal health agencies so that we can become informed more rapidly and implement this part of our standard from a preventive standpoint. Fortunately, PSPC has never actually had a case of Legionnaires disease linked back to any of our buildings. I'll knock on wood, hopefully it stays that way. But we have had detections of Legionella in our system. I saw the panic when you heard that potentially this site was a source of Legionnaires disease cases, which brings to communication and the communication around those incidents. Here's sort of a brief summary of the different testing requirements that we have within our standard. If we look at cooling towers, basically it's weekly dip sliding, so general bacteria levels. Legionella culture testing, minimum once a month, and qPCR testing at system startup, and also following cleaning and disinfections that may have occurred. The reason we do qPCR testing at initial startup is because we can get rapid results. qPCR testing generally takes about 24 to 48 hours to get a result back, Whereas with Legionella culture testing, you're waiting 10 to 14 days to get a result, which is a long time to be operating a system, potentially in a risk state that you're totally unaware of. So that's why we go with qPCR testing right at the beginning of startup, so that we have confidence that we are operating in a clean and sanitary state. However, because qPCR can detect living and dead Legionella, it is always followed up by a Legionella culture test to validate whether there is any living Legionella in the system. Other system types have various requirements. Drain pans, we don't do testing. Again, there's low risk of aerosolization of the bacteria, so we focus more on the maintenance side. But other system types also have testing requirements. So that's a lot of different testing, and it can lead to a lot of data that gets generated on site. We have 3 different maintenance action levels associated with our different test types, and for simplicity and communication within our portfolio, we've color-coded them as green, yellow, orange, and red, and they're assigned with mandatory maintenance actions. We view, in terms of interpreting what those different colors mean, green is an acceptably low level of Legionella in our systems. Yellow and orange can indicate possible amplification of Legionella in the system. And red is definitely Legionella growth within your system. Again, you'll note here that the only test type that will give you a red result is a Legionella culture, because it is the only test that is giving you living Legionella in your system. So with those, Appendix D of the standard for each of the different main system types has those different action levels, maintenance action levels that need to be employed, and then the follow-up maintenance actions that need to follow. So if you're at a red level, the initial maintenance action that you need to follow is immediately stop operation of that equipment and remove aerosol exposure. So if we're talking cooling towers, it's shutting down the fans on the tower or shutting down the tower itself. These colors are sort of meant to align with sort of traffic type signals. So red is stop. Orange we view as sort of the construction side of thing, or you're actually going in and doing something. So that's cleaning and disinfection of the system. Yellow, you're slowing down, contemplating what's going on. So here you're reviewing and adjusting your operation and maintenance procedures based on what the potential causes were for that bacterial growth in your system. And then green, you're going to continue operation. And then those are all followed up by, depending on what type of test triggered that maintenance action, a specified type of follow-up testing that needs to occur. And the only way you really get out of this loop is through a green culture test result. So as I said, a lot of those testing results creates a lot of communication requirements within our organization, and a lot of different people need to get involved. So we developed a communications protocol in 2016 to help streamline those communications. Generally, green and yellow type detections don't require communications outside of the property facility management level, but orange and red will. Again, there because we are cleaning and disinfecting a system, which means that we may potentially be shutting down a system, which could affect the occupants in the building. Our communications protocol has process maps to help clarify roles and responsibilities. We've also developed communication template scripts to help communicate to building employers in our buildings from those 99 federal departments. And we also have more recently developed a program infographic to help with more proactive communication around our program. So these are sort of what the process map looks like, different swim lanes for different responsibilities, and it's broken up into whether it's a custodial responsibility, so that would be us at Public Services and Procurement Canada, or responsibilities that would fall under the various employers from the various federal departments. Also engagement of our corporate communications group. Often, especially if we have an orange or red level detection, it will get into the media. So we will be doing media lines as well as communicating out to various other federal departments. We also have our template communication scripts. The reason we brought these in is I work at the national level. I see every detection that we get nationally across Canada, but locally at the building level, property facility manager may only see a Legionella detection once in their career. So it's unreasonable for them to have all of the communications lines down that they should be using when communicating what actions they're doing. So we developed these templates that they can use and fill in the appropriate information related to the event details, the impacts and risks to occupants, any health and safety information related to that particular equipment type, as well as the detection. Also letting them know what actions are being taken and follow-up testing. And then also pointing them to additional information resources. If they want more information on Legionella, we point out to the Public Health Agency of Canada. We also point out to our webpage that has our standard as well too. That leads me to our infographic that we've recently developed. Again, two here, it's to help provide a snapshot of what I've just been presenting to you in one slide or one element. It doesn't go into the level of detail that we've gone into here, but it's meant to provide reassurance that there is a robust program that is in place in our buildings and that we are taking appropriate actions. Now that's the whole program as a whole. One important thing that is required though, if you do implement a program, is to do quality monitoring on your program. So our quality monitoring program has a few elements to it. One being regular reporting that gets done by our property facility managers and building service technicians. And then those reports are reviewed by our technical services staff, both at our regional level and myself nationally. We have two main reports. One is a semi-annual compliance report to the standard that looks at high-level information related to the status of your LBCMP, and then also specific questions related to the main system types that we have covered in the standard. And then because cooling towers are a more high-risk system, we have a monthly cooling tower report that gets done. Again, high-level information. We want to make sure that startup maintenance was done on those systems and that also startup bacterial testing results came back in a green state, or if they didn't, that appropriate actions were taken. And then we also monitor on a monthly basis what those testing results are for our cooling towers. So that's the regular reporting that gets done. And then finally, we have an auditing program as well too that tries to look at 20% of our facilities on an annual basis, so that on a 5-year cycle, we will have looked at every facility's Legionella bacteria control management program. And here too, the goal of the auditing program is to identify opportunities for improvement and to help drive regional and national compliance to the standard. So the main elements that we look at are, does the facility have an LBCMP? Making sure that all the forms that are required by the standard are in place, making sure that standard operating procedures are present, also related to water quality, reviewing the maintenance logs to make sure everything has been done, reviewing to make sure an LBCMP has been updated if there has been equipment changes at the site. Also reviewing and making sure that there is personal protective equipment for anybody who is doing water sampling or maintenance on the site, and that they have received the adequate training. We do have an internal training course that we offer to all of our operators. And then also the last component is reviewing registration of cooling towers. Not all jurisdictions have registration requirements. In Canada right now, it's only the province of Quebec who has it. City of Vancouver is coming out with registration requirements associated with cooling towers. And then it was also mentioned earlier too, NSF is working with several municipalities here in Canada as well as the US to look at the development of other cooling tower registries. While we're a federal government that doesn't need to abide by provincial and municipal regulations, we do want to support especially these initiatives related to public health, so that if there ever is an outbreak, we can rule out our cooling towers as the potential sources and let public health focus on other potential areas. So if I can leave you with one slide of takeaways from all this, it's a lot of information. First one, I'm going to say be ready to communicate. When we started this, we were focused so much on the technical side of things, and it became apparent when implementing it that communication is by and large the most important component to it, because in terms of Legionella management, there are so many different stakeholders involved with this. There's public health, there's the building operators, there's the design professionals who are designing our buildings. So be ready to communicate at all stages and as frequently and often as you can. From a program perspective, focus at the design, installation, and operation and maintenance of your equipment. Have a site-specific Legionella management plan. Make sure you assess the hazards and risks associated with the systems that you have on site. Ideally, you want to do that at the design stage before they're there, but if you do have existing facilities, late is better than never. Make sure that you're keeping an eye on stagnant water, water temperatures, making sure you're keeping your systems clean, and eliminating or reducing aerosolization if possible. Implement those preventive maintenance activities, and then important as well to monitor the effectiveness of those O&M activities at actually controlling the bacterial growth. Sometimes we think that we have an effective system in place and controls, but unless we're actually validating that we are actually controlling the outcome that we're looking for, we're never 100% sure. Take corrective actions when required based on the reviews of your testing results. And then, very important, do quality monitoring on your program. Education is very important, and any touch points you can have to reinforce elements is great. And as part of that, incorporate any lessons learned. It was mentioned before, we never want to forget mistakes from the past. Very important. Again, too, as I said, a property facility manager may only have an occurrence once in their career, and we need to make sure that they're aware of other issues that have happened elsewhere within our portfolio. And if you do all of that, you should be able to sleep well at night. And then here, finally, is a link to where you can find our Legionella management program. Thank you.
Good morning, everyone. I'd like to thank Patsy and the organizing group for having us contribute to what is a great program on a topic of continuing importance. I'll be giving a short talk today on what the federal roles are concerning Legionella control and risk management, the departments involved, and their activities. I'd like to begin with some background on the basic breakdown of roles and responsibilities in areas relevant to Legionella management. In Canada, responsibilities for health and public safety are shared by various levels of government and involve multi-jurisdictional collaboration and the overlapping of many disciplines. It's really the provinces, territories, and municipalities that have the primary responsibilities for the legislative requirements and the day-to-day operations in the areas of healthcare, drinking water, and building management. But the federal government also has key roles and responsibilities in these areas. One major responsibility is the delivery of programs and services to Canadians, and this comes through activities like communicating information and advice on health and disease prevention, responding to emergencies, and guiding building design and construction. Another significant role is as a landlord and employer, managing Government of Canada buildings and protecting the health of its employees, both domestically and in locations that may lie outside Canada's physical borders. The federal government is a partner in health, working closely with the provinces and territories to meet its goal of Canada being one of the healthiest countries in the world. Recognizing that Legionella control in buildings is an important issue and that the responsibilities for preventing and responding to Legionella outbreaks are shared by multiple federal departments and agencies, the groups involved held a roundtable discussion in 2017 to address strategies within their own departments. They also agreed to develop a document clearly outlining the responsibility of each department and their activities. The intended audience for this document would be those involved in the early stages of building design and construction, and also the eventual occupants, operation and maintenance personnel, and healthcare and surveillance professionals. The document is divided into sections identifying departments with roles before and during construction, after construction, and relating to case management for Legionellosis. I'll be following the format of this document with my talk in describing who does what. So, before and during building construction, the National Research Council has responsibilities. The NRC is responsible for publishing the National Model Construction Codes, which are designed to protect public health and safety relating to the construction and occupancy of buildings and structures. Two of the codes, the National Building Code and the National Plumbing Code, have provisions that deal with Legionella. Now, it's important to mention, while the codes are developed by the NRC, regulating building construction falls under provincial and territorial authority. Therefore, the codes must be adopted by the jurisdictional authority in order to come into effect. The National Building Code, last updated in 2015, sets out provisions for the design, construction, and renovation of new or existing buildings. Within the Building Code, Part 6, Division B, Design and Installation of Heating, Ventilation, and Air Conditioning Systems and Equipment, includes specifications intended to minimize Legionella growth and transmission. These include requirements for the design of evaporative equipment in different applications, minimum distances between things like discharges and air intakes, requirements to protect potable water sources, and requirements for elements that allow access for service and testing. Now, the Standing Committee on HVAC and Plumbing has recently developed proposed changes to Part 6 to further address Legionella. These are to undergo public review before being recommended for the next edition of the code, planned for publication in 2020. The National Plumbing Code, also last updated in 2015, sets out provisions for the design and installation of plumbing systems in buildings and facilities. Provisions under the Plumbing Code dealing with Legionella are in Part A, Section 2.6, Service Water Heaters, requiring that electric storage type water heaters be set to 60 degrees Celsius. This is to address the concern for Legionella growth at temperatures below 60 degrees due to temperature stratification that can occur in this type of water heater. For other water heater types and fuels, this has not been identified as a concern. Now, after construction, several federal departments have responsibilities. The first is Health Canada, who is responsible for developing the guidelines for Canadian drinking water quality in collaboration with the Federal, Provincial, Territorial Committee on Drinking Water. Now, no specific drinking water guideline for Legionella has been established in Canada or internationally. Outbreaks have been linked to Legionella growth in systems occurring outside the authority of drinking water utilities, such as plumbing systems and cooling towers in large buildings. Guidelines that have been established relate to control of Legionella in building water systems and are generally specified under public health legislation established by the appropriate provincial or territorial authority. Now, Legionella is addressed in Health Canada's Guidance on Waterborne Bacterial Pathogens, which provides information on sources of the organism, important areas of exposure, health effects, and the effectiveness of treatment. This document is currently in the process of being updated and is scheduled for posting for public consultation next year. Another relevant document currently being developed by Health Canada is Guidance on Monitoring Biological Stability of Drinking Water in Distribution Systems, which will be replacing the guidance on the use of heterotrophic plate counts in Canadian drinking water supplies. This revamped document more broadly discusses the topic of microbial water quality deterioration in the distribution system, and the issues addressed include biofilms and Legionella. Microbial risk in buildings and plumbing systems is also touched upon. Both documents communicate that for all drinking water systems, the recommended approach for controlling waterborne pathogens in drinking water, including non-fecal pathogens like Legionella, is a source-to-tap multi-barrier approach which includes source protection, optimized treatment and disinfection, meeting the health-based treatment goals for the removal and inactivation of enteric protozoa and enteric viruses, proper operation of the distribution system, and monitoring for multiple water quality, operational, and treatment indicators to confirm the adequacy of treatment and the safety of the distributed water. As I alluded to earlier, the federal government also has internal responsibilities relating to its role as a buildings manager and employer. The Treasury Board of Canada's Secretariat has many responsibilities, including being the employer for the public service. Their Legionella-related work, therefore, relates to occupational health. The Public Service Occupational Health Program is responsible for providing advice to federal departments on assessing and controlling Legionella in Government of Canada buildings. They may also work with provincial and territorial bodies on occasion, sharing their expertise towards initiatives in those jurisdictions. Now, earlier today, you should have heard about Public Service and Procurement Canada's roles and activities from Jeff Moffat far better and in more depth than I could have discussed them. Briefly, PSPC's Real Property Branch has taken on a real leadership role in the federal government, implementing processes for controlling Legionella in Government of Canada buildings, developing a standard for mechanical systems, and a companion communication and actions protocol. Lastly, with respect to Legionellosis case management, the Public Health Agency of Canada holds a number of important roles and responsibilities. They are responsible for developing the national case definitions for Pontiac fever and Legionnaires disease. They also conduct surveillance for Legionella through their work with the provinces and territories monitoring nationally notifiable diseases, and they can help public health authorities investigate outbreaks when requested. PHAC's National Microbiology Laboratory is Canada's main public health lab. The lab routinely isolates Legionella isolates and compares types to international databases to indicate how rare the type is and where else it may have been found in Canada. They can also study strains using whole genome sequencing analyses, which is the gold standard for identification when determining whether cases are linked to the same outbreak. PHAC Center for Communicable Diseases and Infection Control provides guidance to healthcare providers to complement that provided by provincial and territorial authorities. Now, there's no national infection control protocol for Legionella, and most jurisdictions have their own procedures. However, PHAC's publication, Routine Practices and Additional Precautions for Preventing Transmission of Infection in Healthcare Settings, provides a great overview of general infection control principles for preventing transmission of all types of infectious microorganisms, including Legionella, to patients, healthcare professionals, and visitors. And that's all of the information I have to share with you today. Links to the publications I've discussed are provided here for further reference when the presentations are posted online. Thank you again for this opportunity to present where the federal government fits within the larger picture of shared responsibility for Legionella risk management. My contact information is provided below, as is a link to our website for the Canadian Drinking Water Guidelines. I hope you enjoy the rest of this great program.